All right, get ready for this. We're about to go on a pretty wild journey, deep, deep inside the human body. We're going to follow a single, microscopic hero on its absolutely critical mission. This is the story of your heart, told one beat and one blood cell at a time.
So to really wrap our heads around this, let's just start with a number, 100,000. What is that? Well, that's roughly how many times your heart beats every single day.
I mean, just let that sink in for a second. That's a constant, steady beat, never stopping, never taking a vacation. It's the most reliable engine you will ever own, and it's working nonstop just to keep you going.
And if you zoom out over an average lifetime, that number just explodes. We're talking 2.5 billion beats. It's a truly unimaginable feat of endurance, and it's happening inside your chest right now.
So how does this incredible engine actually do its job? Well, you can think of it as running the body's most essential delivery service. And like any good delivery service, it needs a courier.
So let's meet our hero, the red blood cell. Its entire existence, its whole purpose, is to be a microscopic courier. Its precious cargo is oxygen, and its delivery route is, well, your entire body.
And how does our hero carry that cargo? It uses a super specialized protein called hemoglobin. The best way to picture it is like a tiny little transport truck made of iron that can carry 4 oxygen molecules at once. And fun fact, it's this hemoglobin that gives oxygenated blood its signature bright red color.
Okay, so our story starts right after our hero has finished its last delivery. It's running low on oxygen, and it needs to refuel, fast. So first stop, the lungs.
So here comes our cell, looking a little tired, a darker shade of red now. It's traveling through the body's biggest veins and enters the first chamber of the heart, the right atrium. Think of this as the main receiving dock for all the used blood coming back from its trip around the body.
From there, the atrium gives a little squeeze, pushing our cell through a really clever one-way door called the tricuspid valve. This valve makes sure blood only flows forward, right into the next chamber, the right ventricle.
Now we're in the right ventricle, which is one of the heart's 2 major power pumps. With a really forceful contraction, it blasts our cell through another gate, the pulmonary valve, and sends it flying into the pulmonary artery. This is basically the superhighway that leads straight to the lungs for that much-needed refuel. Inside the lungs, our cell winds its way into these tiny little air sacs called alveoli, and this is where the magic happens. It's a super fast exchange. It drops off its waste cargo, carbon dioxide, which you then breathe out, and in that same instant, its hemoglobin snags fresh oxygen from the air you just breathed in. Just like that, our cell is fully refueled and ready to go.
Okay, now it's fully charged with oxygen, it's bright red again, and our little hero is ready for the main event, the Gram Tour. The mission is to deliver all that fresh oxygen to the entire body. But to start the tour, it has to go back to headquarters first. So it travels from the lungs through the pulmonary vein and enters the heart for a second time, arriving in the left atrium. So the left atrium gives a squeeze, pushing our cell through the mitral valve and into the heart's main engine room, the left ventricle. Now this is the real powerhouse. Its muscular wall is way thicker than the right side's because it needs enough strength to pump blood not just to the nearby lungs, but to every single part of your body, from your brain to your toes. And with one massive contraction, whoosh, the left ventricle launches our cell into the body's largest artery, the aorta. This is the main on-ramp for the body's superhighway system. You can even see here how arteries are these thick, muscular tubes built to handle that high-pressure blast, while the veins for the return trip are a bit more elastic.
You know, the easiest way to remember the difference is that arteries always carry blood away from the heart, A for away, and veins carry blood back toward the heart. Veins also have this really cool design, these tiny one-way valves that stop gravity from pulling blood backwards, which is pretty crucial, especially in your arms and legs.
So, after traveling through smaller and smaller arteries, our cell finally reaches its destination, the capillaries. These vessels are so tiny that cells have to literally line up and pass through in single file. And right here, a brilliant pressure system gently squeezes the oxygen off the hemoglobin and delivers it to a waiting muscle cell. In exchange, the cell picks up waste products, like carbon dioxide, to start the whole journey over again.
But what happens when you decide to go for a run? The whole system has to respond to this sudden, massive demand for more oxygen. It has to kick things into overdrive. Just look at the scale of this response. At rest, your heart pumps maybe 5 or 6 liters of blood a minute. Start exercising, and that can easily jump to 15 liters. But an elite athlete, it can surge to a jaw-dropping 35 liters per minute. To put that in perspective, that's like an entire office water cooler jug of blood pumped through your body every 60 seconds. They can do this because all that training has made their heart muscle stronger, so it can push a lot more blood with every single beat.
And this is just incredible. The blood flow to your working muscles can increase by as much as 100 times compared to when you're just sitting around. I mean, your body performs an amazing feat of logistics to make that happen.
So how does it do it? It's basically a three-part trick. First, the heart just pumps faster and harder. Pretty straightforward. Second, your body gets really smart and starts redirecting resources. It constricts the arteries in places that don't need much blood right now, like your digestive system. And third, it does the exact opposite in your exercising muscles. It widens those arteries to flood them with the oxygen-rich blood they are screaming for. It's just a brilliant system.
When you put it all together, from the powerful pump of the ventricles to this huge network of arteries and veins, it's pretty clear that we all have an absolutely incredible engine working inside of us 24/7.
And maybe the most mind-blowing fact of all is just how efficient this whole circuit is. This entire journey we just followed, from the heart to the lungs, back to the heart, and all the way out to the body, the whole thing happens in less than 60 seconds.
Every beat, every minute of every day, this perfect system is working to keep you going. It's just a powerful reminder of the incredible machine we all live in. So, the only question left is, what will you do to keep that engine running strong?